Mistral has just dropped Magistral. In this video, we are going to install this new model from Mistral locally, and we are going to test it out on various reasoning benchmarks. This is Fahad Mirza, and I welcome you to the channel. Magistral is Mistral's first reasoning model. A reasoning model is a kind of model that can think through problems step by step, showing its work like a human would when solving complex problems rather than just providing direct answers. This reasoning capability means that the model, like Magistral, can break down complicated tasks into logical sequences. It can weigh different possibilities and provide transparent explanation for how it reached its conclusion. This new model has been released in two versions. There is one Magistral small at 24 billion parameters for open source use, and then they have Magistral medium for enterprise, and I believe that is also accessible through their paid option. The model is specifically designed to excel at multi-step thinking across various languages and professional domains. I will be talking more about this model, but let me first show you how you can install it and run it. The tool which I'm going to use in order to install this model is VLLM. I already have covered VLLM in a video where I have shown you how to start from scratch and then install it on your local system and start serving the model. All you need to do is to go to my channel, just search with VLLM and watch this first video where we have installed the latest version of VLLM, and that is important. Make sure that you have the latest version. So if you're following along, just watch this video first, install VLLM and come back. I already have VLLM installed. This is my Ubuntu system, and I am using this GPU card, NVIDIA H100 with 80 GB of VRAM, but I will be showing you the VRAM consumption later down the road, and we will see how much you would need to. Now, if you want to confirm if your new VLLM is installed correctly, all you need to do is to run this command, which will show you that Mistral's own common library is installed, and you can see that I have that installed. If you don't see that version, it means that you need the VLLM's latest version, and that's all you need in order to get started. Now the next step which we need to do is to download the model. All you need to do is to just run this VLLM serve Mistral AI Magistral, the model which we are downloading, and you can see it also shows you the date and the month, and then it is giving us a tokenizer mode, Mistral, and all that stuff. So let me run this, and it is now downloading the model, and the model is present in a consolidated file of over 47 gig of disk size, as you can see here. So let's wait for it to get downloaded. Meanwhile, let me also introduce you to Massed Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU or VM or CPU on very affordable price, you can find the link to their website in video's description with a discount coupon code of 50% for range of GPUs. I also want to introduce you to our very good friends at Camel AI, who are sponsoring this video. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws with applications in data generation, task automation, and world simulation. Okay, so while it installs and downloads that model, let's talk a bit more about this Magistral model. And by the way, we have been covering Mistral's model a lot, as you can see in these various videos, DevStral, and then Mistral Nemo, and the list goes on and on. Now, coming back to this model, the model's key strength seems to be in its transparent reasoning. You can actually follow and verify the logical steps it takes to reach conclusions, which is crucial for professional applications where accountability matters. Unlike general purpose AI models that might give you an answer without showing their work, Magistral's chain of thought reasoning works natively across global languages, including English, French, Spanish, German, Italian, Arabic, Russian, and even simplified Chinese. This makes it particularly valuable for specialized fields like legal research, financial analysis, healthcare, and software development. where professionals need to understand not just what the AI concluded, but how it got there. The model also demonstrates strong creative capabilities for storytelling and writing while offering enhanced coding abilities through its methodical, step by step approach to problem solving. And I'm very keen to check out if it does test time scaling or not. So let's wait for it to get downloaded and then we will play around with the model. This is going to take a bit of a time, as you can already guess. Model is downloaded and now it is loading the shards of model onto a GPU. Okay, so the VLLM is now started and model is now being served on our local system. I'm going to use this code in order to access and run and test this model. So all we are doing here is we are simply using this OpenAI compatible API and we are pointing it to our endpoint where local VLLM engine is being served. These are some of the hyperparameters to control the output. We are instantiating the client and then we are specifying our model. This is where system prompt is being downloaded from Mistral's own Hugging Face repo. And this is a prompt which I will be loading from my own file. I will show it to you shortly. And then we are just using this chat completion API in order to get the response back from the model, and then we are printing it out. And now for the testing purposes, what I have done, I have just created this huge scenario based reasoning problem. It's a complex NPV calculation with multiple variables and scenarios. As you can see, I'm trying to balance out competing business objectives and stakeholder interest. I'm also quantifying and comparing different types of risk, multi-step logic. We are also breaking down a complex decision into the components parts like transparency and other stuff. I also want model to be very explicit in explaining of its assumption and reasoning steps. I'm also using some uncertainty trade-offs and ethical consideration. So I'm just checking if model is capable of handling quantitative analysis, if it can reason through competing priorities and constraints, and if it can show its work transparently at each step, and if it can deal with uncertainty. So this is a whole prompt. Okay, so let me open a new terminal and then I'm going to run this code here. And before I run the code, let me quickly show you the VRAM consumption because model is fully loaded onto the GPU. So it is consuming close to 75 gig of VRAM. You would need at least 80 GB of VRAM on one GPU in order to serve this model. Anyway, so let's try to install it. So I'm just going to run this file. And the model was actually quite quick. It has loaded the model. I'll just go up. Model is just thinking. It is saying, all right, I have this complex business decision to analyze for Pharma Corp. And then it is understanding the problem. It is understanding each option. Then it is going step by step in a typical chain of thought way. It is checking its own answer. And then you see that it is exploring different options, different alternatives and probabilities. And it is just following the next step of financial analysis. It is also making some general assumption for that probability. And then it is talking about market size because I have given some of the information. And then it is very correctly assuming some of the stuff where I was vague and not that transparent. So there are some common parameters and it has very correctly identified the NPV, the net present value. Pretty good. I'll just go down. There you go. So I will let it run so that you would also check out how exactly this model is thinking and going through the motions. It has generated the equation by itself. And you see it is just coming up with different calculations. And this is what I was talking about when we were mentioning the reasoning models, that what these reasoning models do, they just come up with so they have a question and they have a goal in mind, and then they come up with different probabilities or rollouts, and then they follow all of those rollouts. And this is where reinforcement learning comes in. So the calculate the score of each of the probability, and they select the probability which has the closest match to the goal, and then they are rewarded there. So this is how reinforcement learning happens, and then it also updates the model's weight. And this is where, if you have been watching my channel, I did a video just, I guess, 2 days ago, and I'm not really sure why it wasn't really got so many views, because I think uh, it's a good video in terms of learning test time scaling, and that is what is happening at the moment. If you check out here, that it is spending a lot more time in thinking and slicing and dicing its own answer. That is where the time has been scaled to spend more time in order to give more nuanced and grounded answer. And I believe that this is going to be one of the features of upcoming and current models in the short run, at least, because that improves not only the quality of the response, but also it increases the probabilities of a correct answer. It is pretty fascinating. As you can see, I know that it is taking a bit of a time, but really it is very, very important to check out how model is thinking, and then it is being very transparent. It is telling you what it is doing in terms of how it is reaching to that conclusion. And so far I can see it is not really printing out gibberish. It is not going haywire, because if you remember the earlier reasoning models, like 3-4 months ago, in between they would just start printing gibberish. Some would even start printing Chinese or other languages, and then they would come back to the actual question. But this one, like many others do, by the way, to be fair, they are staying the course, which is great. Anyway, I will let it run because it seems that it is again a test times scaled model, which is going to take a bit of a time. But this looks like a very good quality model at the moment. It's been 10 minutes and the model is still thinking. I will let it run. And now it's been around 20 minutes, model is still thinking. So, but I believe that we already have got the fairly good idea around its reasoning, with sort of math and all this logical thinking and all the analytical approach it is taking. So very, very good quality. Now, I think it is going to take a bit of a time. So I'm just going to stop it. I'm going to show you another multilingual problem. Okay, so in the next prompt, what I'm going to do, I'm testing its language prowess, as how multilingual it is, and if it can understand technical economic content in 12 different languages. So what I have done, not only I have included the language it supports, but also a few other languages like Urdu, Chinese, Indonesian, Swahili, and even Japanese. So let's see if it can understand that. And the task here is that I'm asking it that you are the chief AI advisor to the UN Emergency Response Coordination Center, and then, sorry, I'm just going to scroll to the right to show you, and I'm saying that a complex global crisis has emerged involving multiple countries, and you must coordinate responses while communicating with local officials in their native language. And then I'm telling it that the reasoning and analysis must be transparent and culturally sensitive. And then the crisis scenario is that a massive cyber attack has simultaneously struck critical infrastructure in 12 countries. Power grids, banking system, and communication networks are affected. Each region has provided situation in their own language, and you must analyze the interconnected impacts, identify the attack vector, and coordinate a unified response. And then these are everything in the language structure. And then there are a lot of things I have asked it to do. Then I am also giving it a bonus challenge and some time constraints. Okay, so let's run this. Again, I'm not going to run it for the full 4 hours, but I will at least show you how exactly it works. And if you are that language speaker, please help us out in confirming what do you think. Now it is giving the response in English, if I just go up, I think it has done wonderfully well. It has checked at all the reports from all the countries, and even when you see in Pakistan, the language is Urdu, India is Hindi, Indonesian is, I think, Indonesian Bahasa, and even Kenya Swahili. That language is not mentioned in its set, but what I have given in those languages, the prompt, it has very correctly translated it into English and understood it very, very well. So these are the attack patterns. I think this model has already passed this test. And this is a primary attack vector. Well done. It says malware and SCADA system. Well done. And then yes, that is correct. It is talking about estimated timeline when it happened. And this is current. Yes, that is true. And then now it is reasoning through every attack vector from every angle. And then what are the similarities? What are the strategic targets? And then all that stuff. You see, so it is also talking about losses, and then it is listing all the countries with daily losses. So this is just sort of like a brain dump, if you please, and that is what I was talking about earlier. And this test time scaling paradigm is thriving. Reasoning models really you can see are continuing to rapidly improve and becoming more effective and really coherent, in my opinion. And even if you check out a lot of benchmark information which they have shared, they have scored very high at cheaper cost. So I will just let it run for a bit and you can just watch. I know that the video's time has become longer than usual, but I think this is necessary in this case. There you go. So even it is doing the number crunching where I was not very clear, but it is coming up with its own equation without, I would say, much hallucination. It is even giving us exchange rates which look pretty good, pretty recent. Well done. So it is going country by country now, and it is going to take long time. So perfectly amazing, I think. Now it is going with France, Spain, UAE. It also checks Arabic. It is even doing the currencies very well, like Indian currency rupee and China's yuan, so Indonesian rupiah. Well done. So it is aware of cultural nuances too. And then it is adding it up, all the losses. And this is just a first step. Okay, this is pretty crazy. I'm just going to go do a quick coding test and then we will call it a day. So let me now stop this. Now for the coding challenge, I am trying to check out as if the model can do some DNA research coding. This checks for variant calling and structural variant detection, population genetics. I'm also checking that if it can do some deep learning for genomic prediction and if it has any capability of federated learning, plus if it can understand distributed systems, GPU acceleration, plus not only it would need to understand the DNA structure, inheritance pattern, but also in terms of coding, it would need to be aware of how to write code for petabyte scale data processing and real-time analysis. The code should be fault tolerant, disaster recovery should be the hallmark, and it should do clinical grade accuracy, end-to-end encryption, audit trail, regulatory compliance, and it should integrate with existing genomic databases and tools. And there are a lot of parts there, as you can see. I'm moving through it. I've even given it a sample. So this is a real world problem where we have maybe existing repo, existing code, or existing pattern, and we want the model to follow exactly the same in order to be compliant not only with regulations but also our existing code. So let's run this. There you go. So yes, it is a massive problem to solve. There you go. So it is now understanding. And this is what I really liked, where it says that let me break it down systematically. So you see, it is very nicely going through. Now as I said earlier, and I keep saying, is that all of this is happening due to the reinforcement learning. Reinforcement learning has enabled this model to do this sort of reasoning, generating a chain of thought. And models are thinking now longer, and which primarily is agentic capabilities. And you can use like search, and it is using Python for calculation, as you can see right now, real time. And downstream tasks can be done like this for calculation and other capabilities. Plus, this better reasoning is giving these models more time to think, and that is where the model has become a planner, and it is now acting like a human. And this is where a lot of people are saying this is the path to so-called artificial superintelligence. Now, as I said earlier, one last bit in this one while you watch, that reinforcement learning is happening, and that is where it has generated the code. Let me quickly go up this. I think, oh wow, there you go. So it has done very, very well, by the way. It has written a very concise code, and I had asked it to generate me a code sample, and then it has done it. I mean, you see, I didn't ask it to write me the code, and it has followed the instruction to the hilt. And I haven't, and this is because I just wanted the code to follow my pattern. If you remember, this is where I gave it my own pattern. So look, instruction following is also quite good, and it's really impressed by the model. So I could talk a lot about this model, but I think one video won't do justice. So I might make another video where we might pick one section like coding and test it on Sui benchmark, and we'll see how it goes. But let me know your thoughts on Magistral. Seems like a some regal magistrate. If you like the content, please like the video and share it. And if you haven't already subscribed, please do so, as it helps a lot. Thank you for watching.